Hey guys, the purpose of this video is to go through the test review and make sure that you know how to work every single question so that if you have a question on one of these problems, you can see it worked out individually for you, okay? All right, let's start with problem 1. So A, B, and C, you are just going to simplify that and write it as a radical expression, okay? So the only thing that you're gonna do is turn a fractional exponent into a radical. So remember, if I have something like x to the a over b, that bottom number b is my radical. That a stays my exponent. So you could write it like this, or you could write it in parentheses with the a on the outside. If it's something where you can actually take the b radical of it or the b root of it, that's when we would put it in parentheses and then put it to the exponent. Parentheses are important. If you start with parentheses, you must keep things for parentheses, okay? All right, so a should be the third root because 3 is in the bottom. And then 10 and x have to go in the radical. You don't have to write the 1 because anything with a 1 exponent just stays by itself, okay? On B, I need you to know that that negative makes it different than the negative on C. On C, that whole -2 has to go under the radical, and that whole -2 has to get raised to the third power, okay? So fourth root raised to the third. Now, on the second one, that 3/4 is only going to the 2. So when I do my fourth root of 2 to the third, that negative is actually on the outside, okay? Now, we have talked about anything to an even, so because this is an even number, so a square root, a fourth root, or a sixth root, if you have a negative on the inside, it is impossible to do that. So just like we can't square root a negative without getting an imaginary number, if you have a negative inside of an even root, that means our answer is D and E. It does not exist. Okay? All right, let's go down to the next section. This is simplifying radical expressions. So everything should end as a radical. It's fine for you to use rational exponents, the fractions, back and forth to get your answer, but you should never end with that. Whatever it starts with, it has to end with, okay? All right, so if I'm looking at problem A, it's a square root problem. So you don't usually write the 2 here, but I'm going to just so you know. You have 2 options. You could rewrite this as fractional exponents, and I'm going to do that one time. So I could rewrite it as 4 over 2, 5 over 2, and 7 over 2, and then pull those out as whole numbers if I wanted to, okay? So a, 4 over 2, would give me a squared. If I did the same thing with b, I would get 2 b's with 1 left over. And if I did the same thing with c's, I would get 3 with 1 left over, so 1/2. Okay, so 3 wholes and a half. All the whole numbers would come outside. Anything left under the radical would come back in here. Okay, that's one way to do it as long as you end in a radical. Okay, for me, the easier way is to say, all right, I need teams of 2 in order to get outside. So if I say I have 4 A's, how many teams can I make? I can make 2 teams. There are no A's left inside. If I say how many teams can I make out of the B's, I can make 2 teams. Oops. 2 teams for B, and then there's 1 left over in here. 1 B did not make a team. Same thing for C's. If I need to make teams of 2 and I have 7 C's, I can make 2 full teams, and there's 1 C inside that didn't make the team. Either way, that boxed answer is your final steps. I don't care which way you get there. All right, let's go to the next one. On this one, you are looking for perfect cubes. So if I think of the number 54, excuse me, some people find it easier to write out factors of 54. So let's say I didn't know I did, let's go 6 and 9. I could factor both of these. That's 2 times 3 and 3 times 3. If I can find a set of 3 or a team of 3, then they can leave. Okay, so a set of 3 can leave. That means 3 is on the outside, and I keep the cube root of 2 on the inside. Now, that negative, think about if you took a negative something, -1, -2, negative whatever, and I raise it to the third power. That's like saying -1, -1, -1. 3 negatives would come out to give you a negative answer. So if I take a cube root of a negative, that's fine. I can go ahead and pull that negative out here. Okay, so one more time. If I have a cube root or an odd number in general, I can pull the negative out here. Don't leave it on the inside, just go ahead and pull it out. Okay, this would be your final answer. All right, let's look at our C. So C, I have cube roots of fractions and square roots of fractions. I'm gonna break those up. Don't start rationalizing anything until you get down to final numbers, okay? All right, so I'm gonna go ahead and take my cube root of that -8. I'm gonna put the negative on the top. I'm gonna take that over a cube root of 27, multiply by a square root, you don't need to put the 2, over a square root of 9. Now, this makes my life easier because I can square root and cube root individually those numbers. Cube root of a -8 is a -2. Cube root of 7 is a 3. Square root of 4 is a 2. Square root of 9 is a 3. And when we multiply fractions, you multiply straight across. So -2 times -2 is -4 across. 3 times 3 is 9, and this is a final answer. Okay? Nothing needed to be rationalized, okay? Because the radicals on the bottom simplify to whole numbers. I don't have to edit them. All right, let's talk about D. So for D, because the radicals are the same, and that's what I mean by these numbers out here, everything can go together straight. So for me, it's easier to think about factors out for the 81 and the 6 if I can write them this way. So if I think 81 is the same as, maybe you know 9 times 9, and then 3 times 3 like this. And then for 6, I'm thinking 3 times 2, okay? So if I look in total for all of this, I'm thinking I have the 5th root of a 3 to the 5th, right? 1, 2, 3, 4, 5. I have a 2. I have a total, if I put the x's together, I have a total of 6 x's. And if I put all the y's together, I have a total of 5 y's. Okay, so that's me simplifying so I know everything that I have. And now I'm going to think about who can leave. All right, so I have to have a set of 5 or a team of 5 to leave. My 3's can leave. I can pull out a set of x's and a set of y's. So I have 3 on the outside. I have a set of x's on the outside and a set of y's. Let's think about who did not make the team. If this is gone, I have a 2 left on the inside. I still have 1 x that did not make the team because I took out 5. And then I have no more y's inside. All the y's made one full team. So this is my final answer. Okay? All right, let's go to F. For F, if they have the same radical, that's what I mean right here, I can put them together. So I notice third root of 5 does not simplify. I could try to simplify 320, but since I know these numbers would divide if they're together, that's what I'm going to do instead. So I'm going to make a big third root of 320 over 5. I'm going to go ahead and divide that. That gives me the third root of 64, so 320 divided by 5. And now this makes my life really easy. Cube root of 64 is just 4, and we're done. Okay. All right, let's go with G. Most common error I see on G is people try to rationalize with a 9, okay? I do not ever want to use a power higher than what I need to. So if I can say 27 over the 4th root of, I could write a 9 as 3 times 3, or 3 squared. So these right now are the same. I'm going to rationalize, and I'm going to put a big R on top so you know what I'm doing. I am rationalizing, which means that I'm going to multiply something over itself. We have to keep it the same. So 4th root. Right now I have 3 2's. I need 4, which means that I want 2 more. Okay? Trying to total up to 4. Whatever I put on the bottom, these guys have to be the same. So you could write 3 squared. Me personally, I like to write 9 so that I know what I'm multiplying with, okay? All right, so if I move over here, now I have the 4th root of 3 to the 4th. I'm adding exponents. I can multiply straight across this way. 27 is a full number. 4th root of 9 stays separate because he's not a radical. If the 27 was inside a radical, then we would do 27 times 9. But they're not. They're separate. Okay? 4 and 4 right here are going to cancel. So let me cancel that out. They don't cancel to 1 though, they cancel to a 3. So I get 1 whole 3 on the bottom, And then my final part here, 27, 4th root of 9. This looks like you're done. The issue is that right here, these numbers can simplify. 27 divided by 3 gives us 9, so I have the 4th root of 9. That's your final answer. Okay? All right, we got about 3 more, and then I'll stop the video and make one for a second page. Okay? All right, for I, my radicals are different, which means that I cannot do these without making the radicals the same. I like to do that with common denominators. You don't have to do it that way, but that's for me the easiest way. So I would rewrite this with fractions. So I have 1a under a square root, so I use 2 as the denominator. For my b, I have 3 over a square root, and c, 1c over a square root. On the bottom, I have cube root, so I'm going to be using 3 as the denominator. A is 2 over 3. B is 3 over 3, C is 1 over 3. Now, all of these have to have the same denominator. Okay, so if I change all of these to have the same denominator, my option is a 6. So I'm going to keep all the same numbers, all the same letters, A, B, C, but I'm going to change them into 6. So 1/2 is the same as 3/6. 3 over 2 is the same as 9/6. 1/2 is the same as 3/6. On the bottom, 2/3 is 4/6 because I'm doubling it. 3/3 is 6/6, and 1/3 is 2/6. From here, I'm going to change colors one more time. I'm going to subtract exponents. Okay? Now, if you have more on the bottom, leave them on the bottom. If you have more on the top, leave them on the top. So when I write this out, I would say, who has more A's, top or bottom? The bottom. 4 is bigger than 3, so I would subtract. 4 minus 3 gives me 1/6 on the bottom. Who has more B's? Well, 9 is bigger than 6, so the top has more. He has 3 out of 6. Who has more C's? The top. 3 is bigger than 2, so 3 minus 2 is 1/6. Now that all of these are the same, I can simplify. Okay? So you are not allowed to leave that radical on the bottom. Okay, so here's what we're going to do. We're going to rationalize again. So I'm going to put a parenthesis and do a big R. I have 1 out of 6. I need 6 out of 6. So we're going to multiply by 5/6, and same thing on top. All right, we are ready to move towards a final answer. We're going to write them in order alphabetically, so 5/6, 3/6, 1/6 over 1 whole A, because I technically have 6/6, so 1 whole A. Okay, remember that if you started as a radical, that's the square root part, you have to end as a radical. So I'm going to take it final step and do a 6th root, because they all have a denominator of 6. I have 5 A's, 3 B's, and 1 C, and I'm keeping that all over 1 A. This is your final answer. All right, last 2. In here, I want you to think of this as one big chunk. Okay, we just call it blah or box. Okay, if I need a team of 3, and I have 4 of them, that means I'm going to take 1 full box out. So I could say A plus 7B on the outside. It does need to be in parentheses. I would keep my cube root, and I would say, how many boxes did not make the team? Only 1. I know it looks weird and like that can't be a final answer, but it is. All you're worried about is saying, I have something to the 4th power, I pull 1 team of it outside, and I have 1 something left inside. Okay, that's a full answer. All right, last one. I want you guys to get in the habit of stop multiplying everything together and then putting it in the calculator. If you ever needed to do a retest on this, I'm not going to let you use the calculator. Okay, so when you're looking at stuff like this, try to use your rules. All right, for me, since these are different, it's easier to go fractions. So I'm going to go 6 to the 1/2. I have 1/6 and it's a square root, times 6 to the 1/3. And then I'm going to wrap them in parentheses and keep it to the 6th power. Okay, then I can distribute this, and I'm going to get whole numbers from that. So 6/2 makes 3 whole, 6/3 makes 2 whole. Okay, and I still have my big bases down here. Okay, that whole thing gives me 6 to the 5th power. That I can work with. Okay, that I should be able to go in a calculator. But I should not be seeing numbers with decimals. I should not be seeing, I don't even know. Yeah, you shouldn't have anything decimals in here. You shouldn't have any giant numbers in here because 6 is your common base. So final answer is 7,770. Okay. All right, we've gone through everything on the first page. If you have questions on the second page, go ahead and watch the second video.